Good morning, everyone. Today I will explain my presentation about paper 223 titled A Human in the Loop AI Agent for Rubric-Guided Formative Feedback in Higher Educations. And this paper is about a very common problem in higher education. Today, AI can generate feedback very quickly, but in education, fast feedback is not always good feedback. So our main idea is this: AI can help prepare the feedback, but the lecturer still needs to check it if necessary, and make the final decision. In the study, we built a prototype to support that process. So, in short, AI helps, but lecturers stay in control. Let me explain the problem with a very common example. A student submit a resource proposal. The lecturer needs to read it and give feedback. Usually, the lecturer already has a rubric, in simple terms, a list of things that should be checked. For example, is the research problem clear? Is there enough literature? Is the research gap clear? Is the method appropriate? And is the academical writing good enough? Now AI can read the proposal and produce comment very quickly, as you can see in your LLM like ChatGPT. But there is a problem. The comment may sound good, but they can still too general. They may not really follow the rubric. Sometimes the AI may also make a statement that is not fully supported by the student work. That is why in our design, the lecturers is still very important. The purpose is not to replace the lecturer. The purpose is to help the lecturer review student work more efficiently and more consistently. Based on that problem, we ask four questions. First, how can AI help lecturers give feedback based on a rubric? Second, how can the system check whether the AI feedback really follows the rubric? Third, how can we make sure that the lecturer can still approve, edit, or reject the feedback? And fourth, what can we learn from this design for building more trustworthy AI system in educations? From these questions, the paper makes three main contributions. The first is a workflow where the lecturer remains in control. The second is a system that combines several steps: finding the rubric, generating feedback, checking the feedback, lecturer review, and keeping a record of what happened. And the third contribution is an initial evaluation of how this kind of system can work in practice. This slide shows how the prototype was built. We use a design science research approach. In simple language, this means that we first identify a practical problem, then build a system to address that problem, and finally test it how the system behaved. The prototype was built with Striprit. For this first study, we did not use real student submission. We used scientific research proposal. We did this intentionally because at this early stage we wanted to test the system without exposing real student data. The rubric contains five simple criteria: problem clarity, literature grounding, research grab, method alignment, and academic writing quality. We also use a local language model through LM Studio. The important point here is that this is an early prototype designed to test the complete workflow safely. This figure shows the complete process in human-in-the-loop workflow. It starts when a student submission is entered and rubric is selected. Then the AI read the rubric and prepare a feedback draft. After that, the system checks two things. Does the feedback match the rubric? And is there anything risky or questionable in the feedback? Then we arrive at the most important part of the process. The lecturer review the feedback, the lecturer review the feedback, and the lecturer can accept it, edit it, or reject it. Only after the lecturer makes the decision is the final version installed. So the important message from this figure is very simple. The AI doesn't directly send feedback to the student. The lecturer is always the final gauge. Here we can see the actual prototype. This is what the lecturer see. The lecturer can look at the original student submission, the feedback created by the AI, the rubric enlightenment report, and the risk report, and the several quality indicators. Then the lecturer makes a decision. There are four possible decisions: approve, minor edit, major edit, or reject. So instead of asking the lecturer to simply trust the AI, the system gives the lecturer a package that can be reviewed. This is very important for us. We want AI to support academic judgment, not replace academic judgment. Now let us look at the first result. We tested the rubric retrieval process using 20 test queries. The hit rate at 1 was 0.85. In simple terms, this means that in most cases, the system found the correct rubric criterions or as its first result. The recall at 3 was 0.95. This means that in almost all cases, the correct criterion appear with the top 3 results. We also asked 5 lecturers to review the feedback package. 40% of the feedback was approved directly. 60% needed a minor edit. There there were no major error and no rejected feedback packets in this early evaluation. What does still what does this tell us? The AI feedback was useful, but it was not perfect. The lecturer still needs to review it. And actually, that support the main idea on this paper. AI can help, but lecturer validation is still necessary. Before the feedback is finalized, the system performs three additional checks. The first is the rubric alignment checker. This asks, does the feedback really address the criteria that the lecturer wants to assess? The second is the risk checker. This looks for things such as comments that are too general, claims may not be supported in appropriate tone, and important rubric criteria that may have been missed. The third part is the audit log. This simply means that the system keep a record of what happened. For example, what the AI originally suggests, what the lecturers changed, and what the final decision was. Why is this useful? Because if we use AI in education, we should be able to understand how the final feedback was produced. This slide compares our approach with more conventional AI feedback. In a normal AI system, we may simply give the AI a prompt and receive an answer. In our approach, there are more control. The feedback starts from the rubric, the lecturer has authority, the feedback is checked before it is used, and the system keeps a record of the process. From this study, we propose four simple design principles. First, rubric first. Second, lecturer authority. Third, check before use. And fourth, keep an audit trail. So our position is not that AI should become an autonomous teacher. Our position is that AI should become a control support tool for lecturers. Let me close with one simple message. AI can generate feedback quickly, but in higher education, speed is not enough. The feedback needs to follow the rubric, it needs to be checked, and the lecturer needs to make the final decision. Our prototype shows that this process can be implemented in one workflow: rubric retrieval, AI feedback generation, alignment checking, risk checking, lecturer review, and audit logging. The first results are promising, but this is still an early study. The next step is to test the system with real student submission, more lecturers, usability testing, workload measurement, and student revision outcome. So the final message is all AI prepares, the system checks, the lecturer decide. Thank you very much for your kind attention.